Out there, beyond the edge of sunlight, beyond the faint breath of the solar wind, a tiny human-made machine is still whispering across the abyss. 47 years after launch, Voyager 1, a spacecraft built when home computers didn't even exist, has just done something that no one expected. It turned back. For reasons no one at NASA can fully explain, the most distant object ever created by human hands altered its orientation toward the very system it left behind. And then it sent back data so strange, so impossible that the scientific world froze. What could make a dying probe billions of miles from home twist in the dark? And what did it see out there in the silence between the stars? It all began in 1977 when Voyager 1 and its twin, Voyager 2, were launched to ride a once-in-a-lifetime alignment of the outer planets. With less memory than a digital watch and power equivalent to a refrigerator light bulb, these probes were never meant to survive half a century. Yet somehow they did. They gave humanity its first glimpses of Jupiter's storms, Saturn's rings, and the icy secrets of worlds we once thought lifeless. And then, as their cameras shut down and their batteries aged, they kept going beyond Pluto, beyond the Kuiper Belt, beyond every boundary we had ever drawn around our solar system. Voyager 1 became the first to cross the heliopause, the invisible frontier where the solar wind dies and interstellar space begins. But when it crossed that line, something strange happened. The magnetic fields didn't shift the way they should have. The plasma density spiked, yet the field direction stayed the same, as if the probe hadn't left our solar system at all but entered a mirror of it. For years, scientists believed Voyager 1 had truly escaped into interstellar space. But new data began to tell a different story. The probe's instruments, 4 of them still functioning, recorded subtle fluctuations in plasma waves like echoes bouncing between unseen walls. The heliopause, the supposed edge of the solar system, wasn't smooth. It was rippling, and the ripples were growing stronger. Then, in 2018, Voyager 2 crossed the same boundary and detected the exact same magnetic alignment. The same density spikes, the same eerie lack of transition. 2 spacecraft, 6 years apart, entering supposedly open space, both finding themselves trapped in identical magnetic conditions. NASA's models couldn't explain it. The simplest conclusion, that the probes hadn't actually left the sun's influence, raised an even bigger question. What then is really out there? Was the heliosphere not a bubble at all, but a barrier? And if so, what was on the other side pressing back? In late 2024, Voyager 1's data stream changed. Its cosmic ray detector, operating decades past its expected lifespan, began registering short rhythmic spikes, each precisely 11 minutes apart. At first, NASA's Deep Space Network dismissed it as system noise caused by radiation interference. But the spikes were perfectly timed, and their amplitude rose in exact correlation with the background plasma waves. Then came the transmission glitch. Voyager 1's antenna, which hadn't moved in over a decade, suddenly reoriented itself by half a degree. The maneuver was tiny, almost imperceptible, yet it required a deliberate command from its attitude thrusters commands that had not been sent. The spacecraft had turned back, not toward the sun, but toward the direction of the magnetic flux it had been detecting for months. And when it did, the data changed. The rhythmic spikes merged into a continuous tone, a steady signal oscillating just below the threshold of human hearing. When the waveform was decoded, it formed something that no one at NASA wanted to believe: a repeating harmonic ratio, matching the fundamental frequencies of the hydrogen atom, the same constant used to encode the golden record. Voyager's message to the stars. That discovery split the scientific community in two. Some argued it was a coincidence, a trick of plasma resonance. Others thought something far more profound had occurred. Voyager 1 wasn't detecting a natural field. It was hearing its own transmission reflected back. The data patterns were identical to the probe's own signal profiles from decades earlier, but inverted as if bouncing off an unseen boundary. A reflective membrane surrounding the heliosphere, absorbing and returning signals like an echo chamber at the edge of creation. If true, it meant that the boundary between the solar wind and interstellar space wasn't an exit, but a mirror. The signal grew stronger for 3 weeks, then suddenly vanished. When engineers at JPL analyzed the final frames, they noticed one last faint voltage fluctuation across the magnetometer. It wasn't random. It spelled out a binary sequence that matched the time code of the Golden Record's very first track. The sound of greetings from Earth. Voyager 1 hadn't just looked back. Something had looked back at it. The engineers at the Jet Propulsion Laboratory worked around the clock. What they had in front of them was a faint and fragmented data stream, almost erased by cosmic noise. But within it hid a pattern that refused to die. When they filtered the raw binary through noise reduction and compared it with Voyager 1's historic transmissions, the resemblance was undeniable. The frequency envelope matched one of the probe's original calibration tones, but reversed and phase-shifted as though bounced off something vast and structured. Using machine learning reconstruction models, NASA's deep space team converted the waveform into a three-dimensional spectrogram. What emerged on the screen froze the room. The signal wasn't chaotic. It had symmetry. 6 repeating spikes formed a perfect lattice, a hexagonal resonance similar to the crystalline arrangement seen in magnetized plasma chambers. The implication was staggering. Whatever Voyager 1 had encountered was not a diffuse gas cloud or random field. It was an organized boundary behaving like a membrane capable of reflecting and shaping electromagnetic energy. Some called it the interstellar wall. Others simply referred to it as the mirror. The discovery couldn't stay contained for long. Within days, observatories across the globe began tuning their antennas to the same frequency range. The European Space Agency's Rosetta Relay, the Indian Deep Space Network, and even private arrays like Square Kilometre Array South reported identical phenomena, tiny mirrored pings arriving exactly 19 hours after every Voyager 1 transmission. At first, the time delay seemed meaningless, until one mathematician at MIT noticed that 19 hours corresponded precisely to the travel time of radio waves bouncing between Voyager 1 and an object located 22 billion km from Earth, the other side of the heliopause. That meant the signal wasn't isolated. It was part of a two-way feedback loop, as if an external structure was not only reflecting but amplifying the probe's transmissions. The more data Voyager sent, the stronger the return became. Then came the truly impossible moment. The same mirrored frequency appeared on Voyager 2, billions of kilometers away on a completely different trajectory. 2 spacecraft separated by the size of the solar system were now receiving the same rhythmic reflection, synchronized to the second. Once both Voyagers began receiving the identical signature, NASA tried to decode it as a message. But instead of language, what emerged looked like geometry. By plotting each frequency spike over time, scientists noticed that the peaks formed a pattern, an expanding spiral, intersected by radial lines like a map viewed from above. When the coordinates were cross-referenced with star catalogs, the intersections aligned with local interstellar clouds, forming a corridor stretching outward toward the direction of Ophiuchus. The pattern repeated every 72 hours, each cycle adding new details as though layers of information were being drawn across the void. The data was subtle but deliberate. The map wasn't pointing outward. It was folding inward, converging back on the sun's position. It was as if the signal were charting us. When engineers converted the numerical ratios into audio, a haunting low-frequency hum emerged, oscillating precisely at the same pitch encoded on Voyager's golden record 115 Hz. The tone representing the hydrogen atom's fundamental frequency. Somehow, something beyond the heliopause was speaking in the same mathematical language we had once sent into the cosmos as a greeting.